Hi all, I welcome you all for the next experiment, that is simulation of a buck chopper. So what we are going to do is we are going to simulate a buck chopper in MATLAB. Okay. So what is the purpose of using a buck chopper? So it converts DC voltage to DC voltage which is lesser than the input voltage. So how much it is lesser means the output voltage V0 is duty cycle times Vin, like this. So we are going to simulate for this given data. So the input voltage is 200 volts, the load requirements is it must have a resistance of 10 ohms, inductance is 1 millihenry, duty cycle is 0.4, so that how much will be the output voltage? Average output voltage will be 0.4 into 200. Okay. So after that we want to measure what is the average value and RMS value of the output voltage. Then in scope we want current and voltage waveforms of output. So these things we are going to simulate using MATLAB. So the circuit of buck chopper will be something like this. So it contains a DC voltage source, so a switching device. So we will prefer IGBT. So here there will be a diode. This is the load. So we are going to simulate for RL load. So the MATLAB circuit will be something like this. After that we will place an LC filter in order to remove harmonics in voltage and also in current. So these are the waveforms, output voltage and output current without any filter. These are the waveforms with filter. So here there is a mistake. These are the waveforms with filter. Okay, we will start now. So you open Simulink library and take a new block, so a new model. Place them in cascade position so that we can easily copy the components that are required for us. So we have seen the circuit diagram. From the circuit, what are the components required that we can place here. So the components that are required for us are available in Simulink toolbox and in Simscape, Sim Power System, Specialized Technology. Simscape, Sim Power System, Specialized Technology. So here some blocks are available. So we will start one by one. First, power guide. It must be placed if you are using any of these components. Place it. Next, enter into power electronics. In power electronics, we want a diode, and then we want IGBT. That's all here. Go back. After power electronics, measurements. So we want to measure current, and also we want to measure voltage. Okay. Go back. Next, machines. We are not using any machines. No need of interfacing elements. Next, elements. In elements, so you can connect ground or you can't. So it is not specific. It is not very necessary to connect ground here in MATLAB. So we want a series RLC branch. If you want, you can connect ground also. Okay, no other element is required here. Go back. Next, go to electrical sources. We want a DC voltage source. Back. Next, we need to measure mean value, that is average value and RMS value. Those blocks are available in control and measurements library. Measurements. So mean block, then RMS block. Go back. Go back. So that's all. So in this toolbox we just want these equipment or these components. Next you go to Simulink toolbox. In Simulink toolbox go to sources. So here what are required for us? We want a pulse generator. Next go to sinks. We want a display to display RMS and average values. We want a scope to see the output waveforms. Next go to signal routings. Here we just want a mux. Okay, so these are sufficient. We can construct buck chopper now. So what we want to construct? Buck chopper. So first bring this DC voltage source, change the name as Vin or Vs, whatever you want, Vin, and you open it. So what is the input voltage? The input voltage is 200 volts. So make it 200 volts. Sorry, 200. Just we want to enter amplitude value. 200, apply. OK. Next we want to place IGBT here. Now you double click IGBT. So we want to make it near to idealness. 0.001 is okay. Next forward voltage you reduced to 0.01. Apply. OK. Next bring the diode. So diode also make it to near idealness. 0.00. Apply. OK. So we don't want this measurement output terminal. So you can untick this. In diode also you can untick that measurements output port like this. Next we want to connect load. So it is in horizontal position. To change it to vertical, control R. Rename it as load. And now open it by double clicking. The type of load is RL load. So resistance is 10, inductance is 1 millihenry. Apply. OK. Now you can see the load as RL load. Now you do the wiring. Okay. So values are entered. Values are entered in Vin. IGBT also we change the diode, we change the load values, all those things. Now the triggering for IGBT. So gate pulse. Change the name as gate pulse. G underscore pulse. You can give whatever be the name you want. Connect it. Now double click it. So amplitude is 5 volts. Usually microcontroller's output will be 5. Period. So you can see it must trigger at a frequency of 10 kHz. So the period must be 1 by 10 kHz EQ. So the duty cycle is 0.4. Duty cycle is 0.4. That is 40%. There won't be any phase delay. So you leave it as it is. Apply OK. That's all. Now we want to see what is the output voltage. So bring this voltage block here. Change the name as V0 and you connect it here. We want to see what is the output current also. So connect the current measurement. in this scope I want to see what is the output voltage waveform and what is the output current waveform. So to see two waveforms, we want these two to be connected to the scope, but here there is only one input port. You change it to two input ports. Double click on the scope and you press it. Change the number of axes to 2. Apply. You can see 2 are there. So the time scale is only on the lower graph. To get the time scale on the upper graph also, in tick label all and apply. Now you can see the time scale in both the graphs. Press OK, close this. Now you connect it. So I want the upper one to be V0. I want the lower one to be I0. Next, for output voltage we want to measure mean value and also RMS value. So we can see them on display. To obtain same display, control and drag it down. So in mean, you can change the fundamental frequency. So this is same as that switching frequency. So it is 10 kilohertz. Here also 10 kilohertz. Initial RMS value, you can give any value. So I am giving it as 100. So you save it. I want to run this for a time duration of 1 second. So change the simulation time as 1 second and you once again save it and you run it. So auto scale the waveforms so that you can see the waveforms. To zoom them. So what type of zoom we want? I just want only horizontal zoom. That is, I want to zoom the x-axis. So to zoom x-axis, so zoom x-axis. You press on this and simply you zoom it for some duration. Now you can see. So during 40% it is on and 60% it is off. During that duration, the current waveform is like this. So to see them clearly, we change the y-axis. Axis properties. I want to see from 0 to 10 volts. Apply. Now you can see. So here also you change it. That we want to see from 0 to, let us say, 11 amps. Apply. So these are the waveforms that we got. So what is the average of this? So the average of this is, close this, you can see it as 80 volts. Okay, that is 200 is the input. 200 into duty cycle is 0.4. Duty cycle is 0.4. So 0.4 into 200 is 80. So that you can see here, mean means average value is that much. This is the RMS value. So to see this in here, what we can do is, in the same input we want to send two signals. One is the mean signal, the other one is this output signal. So you remove this and you can mux those two signals. Bring the mux. One is this, the other one is this one. These two must go to 0. Now you save it, run it. So here you can see it is compiling. As the switching frequency is very high, it takes lot of time. Okay. Now you can see the waveform. You can see the mean value of this is 80 volts. If we change the duty cycle, accordingly the mean value will change. So if you see the output voltage is like this. So for 40% it is 200, for 60% it is 0. So there is a lot of distortion in the waveform. There is a ripple content in voltage waveform is very high. So we need to filter this ripple. And in current also there is a ripple. So from 7 it is going to 10.5, again it is falling to some 5.7, something like that. So there is a large ripple of 5.7 to 10.5. We want to eliminate that also. So to eliminate ripple in current, we want inductor. To eliminate ripple in voltage, we want a capacitor. So we place a LC filter there. Bring it back. Here we will place a LC filter. So control and drag. Again control and drag. And we will change this. Let this be L filter. Let this be C filter. Open L. Let us say it is 10 millihenry. So C. Let us say it is 10 microfarad. So L filter will be placed in series. Filter will be placed in parallel. Now you save it and you have seen the previous waveform. See, voltage is having this ripple, current is also having a large ripple. Now we placed LC filter. Now you run it and we will see the difference. Can see here. So there is no ripple in voltage waveform. There is no ripple in the current waveform also. They are very minute. Okay, you can see from 79.9 to 80.25. Just a small ripple. You can change the axis properties from 0 to 85. So very minute ripple is there. For this one also, I change it from 0 to 10. So here also the ripple content is very small. So designing this in such a way, we need a capacitor which is of 10 microfarad, which is costly. So you can bargain between the limits. So here we reduce it very small. So if the customers accepts from 7.5 to 8.5, then we can reduce the values of inductor. Here if he satisfies with the lesser, with having some ripple, if he is satisfied means, we can change or we can reduce the value of capacitance so that the cost can be reduced. And here also you can see the mean value is 79.98, that is nearly 80 volts. This is also 80 volts. So we know that for DC average value and RMS value are same. So that is what we got here. So like this we can simulate a buck choker. Thank you for watching.